Hello guys, and welcome to another video. On this video we are doing question 4 of June 2024 grade 12. Here the statement reads that a learner standing at the bottom of a building throws ball A vertically upwards at a speed of 11 meters per second, and ball A reaches a maximum height T after 0.72 seconds. Another learner standing on the roof of the building throws ball B upwards. The two balls reach point T at the same time as shown in the diagram below. This is our diagram, and we see that ball A is thrown from the ground going up, and then ball B is thrown from the top of a building going up, and they both reach maximum height T. Now guys, I'm going back to reminding you that if an object is thrown, then it should have an initial velocity. That means the velocity has to be greater than 0. But if an object is dropped, then the velocity has to be equal to 0, the initial velocity. I should be specific there to say the initial velocity. And here we can see that our balls are being both thrown, so they both should have initial velocities that are greater than 0. Now let's go to our questions. Our questions are saying, what is the difference between free fall and projectile motion? First and foremost, both of these things are motion, right? But if I specifically look at free fall, I'm going to say that free fall is what? It is the type of motion whereby the only force acting on an object is the gravitational force. That's what free fall is, right? It's the type of motion whereby the only force acting on the object is the gravitational force. That's free fall. And then when you go to projectile motion, it is a type of motion, but we say that projectile motion is the type of motion whereby an object is given an initial velocity and it's moving, and the object is moving under the influence of force of gravity only, or under the influence of gravitational force only. Let me repeat that. Projectile motion is the type of motion whereby an object is given an initial velocity and it moves under the influence of gravitational force only. Yes, that's how we define those two things, or that's how we differentiate them. I hope that makes sense. All right. And then we go to 4.2. 4.2 says calculate, firstly, the time taken by ball A to reach the maximum height at T. The time taken by ball A to reach the maximum height at height T. So this one, guys, wants us to find what? It wants us to find time. And we know that for us to find time, we would have to use a formula that has time. But the formula has to have the information that we have. If we look at ball A, we know its initial velocity. And we also know the acceleration of ball A, but it's a question of whether the acceleration is positive or negative. But we know the acceleration is going to be 9.8. And we are looking for time. So the formula that we use, we also know the final velocity, guys. The final velocity is 0, because we know that when an object reaches maximum height, this is where our maximum height is, the final velocity has to be equal to 0. So to answer this question, we are going to use a formula that has all of this information: initial velocity, acceleration, time, and final velocity. And that formula, guys, is this one here. Vf is equal to Vi plus A delta T. My Vf is going to be 0. But before I go into substituting, guys, let's remember that when we are dealing with VPM, we have to consider direction. And I normally take the direction of motion as positive. So since this ball is being projected in the upward direction, I'm going to take positive as upward, or rather I'm going to take upward as positive. For me, the upward motion is positive, meaning that anything that goes in the downward direction will be negative. So my VF is going to be 0 is equal to my velocity is moving in the upward direction, initial velocity, so it's going to be positive. And then I will have my acceleration. Obviously, this is acceleration due to gravity and it moves in the downward direction, so it's going to be negative. And this is my delta t, the one that I'm looking for, delta t. And what I'll do is to transpose this 11 to the other side. It's going to be negative 11 is equal to negative 9,8 delta t. Then I'll divide by negative 9,8 on both sides. And therefore my delta t, when I press this on the calculator, my delta t becomes 1,12 seconds. So this is how I answer 4.2.1. All right, hope it's making sense, guys. Let's move on to 4.2.2. 4.2.2, guys, wants us to find the initial velocity of ball B. We know that ball B was thrown vertically upwards. That's why, because of it being thrown, it's supposed to have an initial velocity, but we do not know the initial velocity. And another thing, guys, we know about ball B is that it was thrown 0.72 seconds after ball T was projected. When you read the statement, they said that ball T was thrown vertically upwards, and then after 0.72 seconds, another learner standing on the roof of the building throws ball B upwards. So what you will realize is that, guys, the ball A has traveled for how long? It has traveled for 1.2 seconds. This is the time we just found. It traveled for 1.2 seconds going from the ground up until it reached maximum height. So we know that from this point to this point, the ball traveled 1.12 seconds. And then another thing we need to realize is that ball B was thrown 0.72 seconds after this one was in the air. So 0.172 seconds must have been here. You see this part here? Let me just shade that part. So from the ground up until this point that I've highlighted in green. So from the ground to up here, where I've also highlighted in green, the ball had traveled for 0.72 seconds. So what we have to do is to find the time. What we have to do is to find the time from here up until here. The difference between here and here. How are we going to find that difference? Because it's the one that will help us to know how long ball B traveled in the air. So from this part to this part, we need to figure out the time there. And the time there can only be figured out by subtracting 0.72 seconds, because 0.72 seconds is here, right? 0.72 seconds is between this first green part and the second green part. So for us to figure out what is the time here on the yellow parts, we have to subtract 0.72 seconds from the overall time. I hope, guys, you can see that, right? We are finding the difference here, and we can only get it by subtracting this to get what's going to be here. And that's the time it took for ball B to travel. Okay, so that's how we'll do this calculation. And the formula we'll use again is the one that we just used now. VF is equal to VI plus A delta T. Our VF, again, because ball B will travel and reach maximum height, the final velocity has to be 0. Initial velocity in this case is what we want. What about the acceleration? The acceleration, because we are moving upwards, will be negative as well, because it goes in, it's moving in the downward direction. And for the time is the difference, right? The time is the difference here. So I said that the difference we'll find by saying 1.12 seconds, the total time traveled by ball A, minus the time after which ball A was thrown. So it's going to be 1.12 minus 0.72. Let me just try to make this fit in. So with this one, we will have 1,12 minus 0,72, and from here we can let the calculator do the job. I'd have 0 is equal to Vi. I don't know what the answer is here. Let me just calculate it. Okay guys, my calculator is giving me a value of negative 3,92, and I'm gonna transpose this negative 3,92 to the other side. So Vi will be equal to 3,92 seconds. This time is the time, or rather this, oh my word, why am I saying seconds? My bad guys, forgot that we are looking for velocity. It's gonna be meters per second. So this is the initial velocity at which ball B was thrown, and that answer is 4.2.2. So Vi here is equal to 3,92 meters per second. I hope guys it makes sense. Now we move on to 4.2.3. They are saying we have to calculate the height h of the building. How are we gonna do that one? Okay, let me just clear up my space here. All right guys, so the height we are looking for is this one here, this height. This is the height that we are looking for, the height of the building. And the way in which we are going to find this height is to use the same approach we did for the time. Do you remember that for the time we had found the time that ball A traveled, which was the total time, and then we also we then subtracted the difference from that total time. So we are going to do the same thing in this case. What we are going to do is to find, I'll highlight this in yellow, we are going to find the height from ball A to the maximum height T. That's what we are going to do first. And then the second thing that we are going to do is to find the height, or rather, the height that ball B traveled. I hope you're following guys. And after doing that, we will subtract the height of ball B from the height of ball A, and that's gonna give us this difference here. Because once we find that difference, let me just use a different highlighter for my difference. So for the difference that we are gonna find is here, and that difference, the one highlighted in blue, is this height. So we find the yellow height, find the green height, subtract the green height from the yellow height to remain with what? The red height or blue height. I hope you understand this. And the formula we will use is gonna be VF squared. We choose a formula that has height, guys. This is the one I prefer. VF squared is equal to Vi squared plus 2A delta Y. Yeah, this is our formula. You can use another formula, guys, as long as it has the information you need. What are we looking for? We are looking for age, so we need a formula that has delta Y, and based on the explanation I gave, this is the type of formula that works for me in this case. You can use any other formula. And then we will remember that Vf squared is the final velocity at t. Final velocity is supposed to be 0 squared, right? And then we go next door. Next door, we expect the initial velocity to be squared, and the initial velocity for ball A, because we are still finding the height for ball A. The initial velocity for ball A is going to be 11. You also have to remember direction, that our direction is what? Upward, as positive. Upward is being chosen as positive. So the velocity has to be positive, and then we say plus 2 in brackets. Since upwards is positive, A has to be negative. Then we'll have delta Y there. Then this will be 0 is equal to, this one is going to give me 121 minus this one is going to give me negative 19,6 delta Y. Then I'm going to transpose 121 to the other side. It becomes negative 121 is equal to negative 19,6 delta Y. Then I divide by negative 19,6 on both sides. And now my delta y for ball A, which is the height, the height for ball A is going to be it's going to be 6,17 meters. When I put this on the calculator, that's the answer I'm getting. All right, hope you understand, guys. So step number 1, find the height for ball A, and now we find the height for ball B using the same formula, same procedure. So the formula is already written. I don't have to write it once more. I'm just going to substitute into this formula. For ball B, the initial velocity has to be what? The initial velocity, guys, has to be, why am I saying initial? The final velocity, rather, it has to be 0 is equal to. What about the initial velocity? Remember, we found the initial velocity as 3,92. We will square it, and then we will say minus, or rather plus 2. Let me just fix here. We'll say 2 multiplied by negative 9,8. Remember that because we chose upwards as positive, the acceleration due to gravity has to be negative since it's moving the downward direction. Then we will square this one. I don't know this one. Let me just quickly find my answer. I don't know what the value is for this one. Alright, guys, so this one is gonna give me 15,336. Okay, no, I forgot the value. Can I just go double check? It's gonna be 15. Just double. Okay, it's 15,3664 minus 19,6 delta y. Then I'll transpose this one to the other side. It's gonna be negative 15,3664 is equal to negative 19,6 delta y. Then I divide by negative 19,6 on both sides. These cancel, therefore delta y in this case will be equal to, put this on the calculator, and the answer we get there is 0,784 meters. Remember what I said? I said we would find this height, find this one, and then subtract the height for ball B from the height of ball C to get h. So what I'm going to now do to conclude is to say h is equal to 6,17, the height of ball A, minus 0,784, the height of ball B. And the answer that I get is going to be 5. If I press this on the calculator, the answer I get is 5,39 meters. There is your answer, guys. I hope it makes sense as to how you should get that answer. Fun stuff. Now we move on to the next question. The next question says the following position time graph is given for the motion of the two balls A and B as described above. Study the graphs and answer the questions below. This is our graph, and it's the position versus time graph. And if you analyze this graph, you will realize that this side position is for our heights, then this side we have our times, and this is the motion of ball A. Ball A started on the ground and then it traveled up until it reached maximum height. Ball B traveled, ball B was thrown from the top of the building until it reached maximum height. So X is T actually. X is T, our maximum height. What is Y? Y has to be H, because Y is the height of the building. Yes, and you have to remember that the ball was thrown from the top of the building, so Y has to be H. And then Z. Z is when ball B was thrown, right? And ball B was thrown after 0,72 seconds. So Z has to be 0,72 seconds. W is the time it took for ball A to reach the maximum height, and that time was 1,12. Remember when we made those calculations? And from that, guys, you see they are saying write down the value and unit for X. We've already said that X was the maximum height for ball A, so x is supposed to be 6,17 and it's in meters. What about y? We said y is h. It is the height of the building, and we just found it as 5,39. It's in meters. What about z? We said z is the time after which ball B was thrown, and that time was 0,72 seconds. And then we have w. W, we said, is the time it took for ball A to reach maximum height, so it's going to be 1,12 seconds. And guys, that's how we answer this question. I hope it made sense to you. Please be kind and like the video. Do share it with your friends as well. I'll see you on the next one. Bye bye.